Good morning. Today I'm going to start the lesson, the irrigation structures. And the irrigation structures, one of the topic is stream gazing. What is the stream gazing? It is a technique used to measure the discharge or the volume of water moving through the channel for a unit time. So what is flowing through the channel? You measure in a particular point. Or we can say like this, the height of water in the stream channel known as the stage or gauge height can be used to determine the discharge in a stream. Stream flow represents the runoff phase of the hydrologic cycle. It is the most important basic data for hydrologic studies. Stream flow is the only part of hydrological cycle that can be measured accurately. Runoff from the catchment can be determined to measure the discharge of the stream drainage. So these are some important points of the stream gazing. So another one is the necessity of discharge measurement. So this is very important. We should be know the importance of discharge measurements in particular stream and particular point. It's very important. By measuring the discharge in a river, irrigation water can be distributed uniformly. This is very important. You supply water uniformly, not only irrigation and different purpose. The storage of water in a reservoir with help of the dam. That water we can use for the various purpose. Irrigation purpose, domestic purpose, navigation purpose, debris control purpose, flood control purpose, and generation of power. So these are the so many purpose. If you know the all the purpose, we can be distributed water properly. Properly. And second important point is that when measuring the flow in a river flood, warning can be used. Warning can be used. By measuring the flow, canal quantitative loss can be known. So with help of the gauge, we can be measured how much loss in a canal. And finally, the quantity of water flowing in the river helps for future research. Future research. So these are the necessity of the discharge measurement. Next, site selection of stream gazing. This is also important point for the stream gazing. So one is already we discussed what is the stream gazing, and selection necessity of stream gazing is over. And site selection of stream gauge. Very few important points I explain. I give you some inputs for you to understand for the what is stream gauge selection for the site. The bed and banks of the stream should be firm and stable so as to ensure consistency of area discharge relationship. So, and second one, the bed and bank should be free from the vegetable growth, boulders, or other obstruction like piers. This is very important. Free from the obstruction, measurement of discharge and a particular point, it should be free. There should be no longer overflow section at the flood stage to ensure good consistency between the stage and discharge. There should be good control section or downstream of the gazing site. The stream gauge station should be accessible, easily accessible, and very important to ensure good consistency between the stage and discharge. There should be good control section downstream of the gauge site. Means the section should be straight and uniform for the length about 10 to 20 times width of the stream. It's very important. 10 to 20 times width of the stream. So next one is the stream flow measurement technique. So many methods. Okay, so many techniques. There is one is the direct determination, and second one is the indirect determination. Look into the slide so that you understand the direct methods from A to D, and as well as the second one is the indirect measurement is the so A and B. There's a two methods. In this case, I want today I plan to explain two methods. One is the area velocity method, and second one is the avant to floating method. The both are used for the measurement of the velocity. The first of all, area velocity method. Look into this slide. Look at this slide. So these slides are clear to understand how to measure the area and as well as the velocity, as well as the elastic. Just as for the diagram based or the figure based, the first important point is the area of individual portion can be easily calculated if the bed profile and stays no. How to know this one? Bed profile and all those things is a very how to know this one is the first of all you can be the area the each the accuracy point of view, the area is divided into number of equal segments or divisions. This is a very important. This is very based on the accuracy required. Width of the stream is divided into number of vertical portions. That is very important. First, number of vertical portions. Look, this is the stream is divided into number of the vertical portions. Number of the vertical portions. And second one is the what is the each portion. The velocity is measured at one and more points along with the depth to get the represent to velocity. We know the area. How to get the area here? So we know the length and factor one point to another point. This is the point one and point two, point three, and so on. We know the L1 and as well as the D1. So we know the L1 and D1. Then we get the area, and as well as we measure and put a point velocity and different equipments. The velocity may be measured in the conventional method or advanced procedure. Then we get the discharge. How to get the discharge? How to get the discharge? Very simple. The discharge is measured Q is equal to A into velocity. A into velocity. This is the simplest method. Simplest method. Okay. This is the area velocity method. I will continue next method, that is a float method. That is a post method. So the first recollect what we discussed for today. What we discussed today. The first one is what is a stream gauging? What is the stream gauging? So what is the second one is the necessity of the discharge measurement, and third one is a site selection for the stream gauging. Site selection for the stream gauging.